Okay, so this next part is on copying arrays. Very often in a program you want to just copy something. And you can do that in an array. It's not that complicated, actually, to copy an array, but there are some utilities that help you. One simple way would be to use a loop. Here's your source array. You create the target array based on the length of the source array, and you use a for loop to copy each element. That's pretty simple and straightforward. You definitely could just do it that way. But there's also a utility under system called array copy that will do it for you. And I have to admit, I've actually never used this utility before. Let me see if I have it somewhere. Or we can just come up with one ourselves. Just create a new one here. So certainly we can come in here and do this. Oh, you got a typo on there. Resource array. Do that. But it looks like they're also saying there's under system there's a array. Oh yeah, there is array copy. Look at that. It's interesting. I've actually used this before. I wonder if that's new for Java 5. From one array to the other array, and it looks like you've got some options of starting in a position, so not copying the whole array, but copying from a start position in the first array, and then to the output in the second array, and it gives you different options. The source argument is the first, destination, let's see what this thing is. So you could do that. Sorry. So args, I believe this will be the source array, which would be this one here. We'll just say from 0, target array. Not sure what they mean by these. These might be let's see what it says about it. Source array 0, target array 0, source array dot length. Oh, okay, alright. This will be 0, and then this will be source array dot length. And essentially it's doing exactly what we've got in here, so we don't need this for loop. Just replaces the for loop. I don't know if there's some efficiency gain by using this utility or not. Sorry to hear about that, Daniel. Now, next thing is talk about passing data, and we talked about passing by value already when I said that in simple variables like an integer or a double or a float or a character, it's very simple to pass the data. You just pass it, and a copy is made. It's like one page out of a book. You make a photocopy. You give your friend the photocopy, and if they mark it up, they're only marking up the photocopy, not the original. An array, and that's what we would call a simple data type. Arrays are like objects in that they're complex data types, which means they don't hold a one small piece of discrete memory that's easy to copy. An array is more like a book than a page out of the book. So if you've got War and Peace and your friend wants page 10 from War and Peace, that's not a problem to make a photocopy of it. But if they need the entire book, you're not going to photocopy the entire book. You're going to give them the book, and you're going to ask them very nicely not to mark it up and to return it. But you're giving them the original book. And arrays are passed to methods in much the same way. Instead of passing a copy of the value, it actually passes the memory address so that the method is modifying the same exact memory. And that may be a good thing. There's advantages and disadvantages to both. Sometimes you want it to be able to do that. Now, you can give something called an anonymous array, which is where you create the array right in, right there. And printing the array would be, really straightforward if you wanted to do that. So you can create an array right on the fly and pass it in. And essentially, that's okay, but that's not typically the way you would do it. So pass by value. Java uses pass by value to pass arguments to a method. There are important differences between pass by value and of primitive types, which is how they're always passed, and passing arrays. Remember, a primitive type is small, it's discrete, it's easy enough to make a copy. For arrays, it's not so easy to do that because it can be quite a bit of memory. So for passing an array type, the value of the parameter contains a reference to the array, essentially the memory location where the array is stored, instead of a copy. Right, so we've got this example here, this test example. Copy and paste this. Let's go crazy. Let's call it array test. Okay. So we created an array 10, and we're saying M, which looks like it's doing a receiving. Oh, okay, so it's going to receive an X and Y, which is a number and a simple integer in an array. And what we're going to see in M, which is our test, is it's going to assign the number 1001 to number, which really is X, or a copy of X, and number sub 0, it's going to assign 55555. And because numbers is an actual reference to the same location in memory as Y, basically what we're going to see is that X will not get changed after the call, but Y sub 0 will. Right, so Y sub 0 gets changed, but X remains the same. And the reason for that is because X gets sent as a copy, because it's a very small value. It's just a page from the book, but Y is the entire book. So the entire, well, not so much the entire book gets sent. You can think of it that way, but what actually gets sent is a reference to that first place in memory. So it's, in the case of an array, you're manipulating the same exact memory. In the case of the primitive type, you are only you're manipulating a copy of the memory, not the actual original memory. So that's why, and that essentially is copy. This will probably show the call stack how it works. Numbers is a reference to a location in memory, pointing to the same location in memory. So, and that's a different. It's memory, but it gets placed into one place in memory. Yeah, remember that's a reference to that location in memory, still in the main method. Do I have this? Test pass? Alright, let's see if we do that. Difference between primitive types and arrays. So we looked at that already, right? So I mean, the main difference is that with the primitive type, copy is always sent, and with a non-primitive type or a complex data type such as an array, an actual reference to the memory. And this is really because of memory efficiency more than anything else. Duplicating 4 bytes of memory or 8 bytes of memory is nothing. But if you have a big array that's, 400K, it starts to become inefficient on your memory to make copies all the time. Plus, you'll run out of memory. So it's more efficient to send the actual memory location, a reference to where in memory it's at, than to copy it. So it's more of an efficiency thing. If it's small enough, make a copy, but otherwise, just send the original. So I think, again, it shows you A is a reference. It's called on the heap. The memory is broken down into the heap and the stack. The heap is more volatile memory. No, is that true? No, the heap is less volatile. Excuse me. Stack is more volatile. Swap will swap two numbers. A and 0 pass to swap. And it depends upon how you pass it. Now, if you pass the entire array, like so for example here, reverse. Creates an array, lists out length, it passes it in, the entire array, and then this thing simply swaps them, right? Reverse. Let's take this. That's part of the same for loop. So what it's doing is it's swapping them all around. Yeah, I don't like what this thing is doing. It's reversing the order. It's using a for loop where it's initializing two values. I is starting at 0. J is the length minus 1. And then while I is less than the length, increments I, decrements J, and essentially swapping the arrays around. So if I were to pass in, forget about that for right now, but if I were to pass in okay, so all zeros right now. Probably we'd want to put something in here. Let's take those. Okay. And then, this time we'll call reverse, right? And then we can print the whole list out again. So, say 4. We should see this list being reversed. So 68 would be first, followed by 54. It didn't seem to do that. Hello. Run. Gave it to us in the same order. Well, that's interesting. It didn't seem to work. Oh, I see what it's doing. What's now? So here you almost have to say y equals that. Okay, it works that time. And the reason being is that it actually didn't modify the original array. It created a new array and reversed it by putting it into a new array and returned the new array. So it didn't actually modify the original memory. Now, we could have done that, but it didn't actually do that. So going through it creates the new array, and it creates a for loop where it's initializing two values and also working two different indexes. And we kind of said not to do that with for loops, but they're doing this in this example, which I'm not too crazy on. And it's going to go through, essentially going through, and it's just reversing it. Since I starts at 0 and J starts at the end, it's just taking pulling off the last one and repopulating it. So you can see what's happening there. All right. You know what? Let's just break right here. Yeah, because it's already 7:45. Some questions on the midterm. Yes, midterm will be multiple choice, maybe some true and false. No programming involved. I mean, I might give you a small code snippet and say, what's the answer to this, and A, B, C, or D, or something like that. That'll be multiple choice. Any other questions?